not in this class, but so we want to look at the distributive property. We're going to look at it. Well, you know what the distributive property is. What is it? Yep. You're going to take what's in front of the parentheses and you're going to multiply it through every single term that's inside the parentheses. That's the distributive property as you know it. We're going to look at that in a little more in depth because we're going to have rational numbers involved, which means fractions, and it's going to be variables. So we're going to work with how we make this look simpler. We are also going to look at solutions of equations. That means the value of the equation. We're going to find that. And then we want to talk about how when you move something over to the other side, you really change the sign. Just means if it's positive on one side, you're adding it. So to move it to the other side, you subtract it. Just means you're changing the sign is all. Okay, so a little bit about the distributive property. I don't know about you, but if you don't like math, that does not look very fun to do. So what we want to do is be able to find a way to simplify that so it doesn't look like such a terrible problem. And if you can just look at each individual fraction and write that so it is what I like to refer to as linear, or it's all in the numerator. If I take denominator values and I move them to the numerator, then what do? Yep, you change the sign of the exponent. So if we look at this very first fraction that's out in front that we want to distribute through, if we look at that, we can put that all into the numerator by moving the b up. And if I move that b up, I'm going to get 4a squared b to the negative first. The next fraction, if I look at it, we have b to the negative second, but we want to move a to the fourth up, which makes it a to the negative fourth. Then we have minus 3b. If I move this a up, it becomes a to the negative second. What happens when you group those two a's together? A to the negative first. We want to add those exponents right there. There's your problem. Does this problem look better than this one right here? Yeah, no fractions, right? It's got to look better, I hope. So what we need to do is we need to multiply those values together now by distributing. To distribute, we're going to take 4a squared b to the negative first, and we need to multiply by the green. So we're going to take the red times the green. What do you do when you multiply those? 4a to the negative second, b to the negative third. So you're adding those exponents. Now we want to take the red times the blue, and if I take this red part, distribute it to the blue, you have 4 times negative 3, which is negative 12. A to what power? Not just a, it would be to the 0 power. If you leave it as just a, what's that exponent understood to be? A 1. So we can't do that. B to what power? Negative 1 plus, this is understood to be a positive 1, which is just going to give you 0. Now, anything to the 0 power is what? The number 1. So we could look at this as minus 12 times 1 times 1, which means your answer is just 4. A to the negative second, b to the negative third, minus 12. And you keep your answer in that format right there. Now, some of you, as you're going through and you say, oh, that's a to the 0, you probably just keep the 12 there and you don't put anything down. That's b to the 0, you don't write anything down, and you got your answer here without having to write those 2 steps right there. It's okay, but if that 12 was not there, Your answer is just not this purple value here. This over here, if the 12 was not there, you would have to put it as a 1. You can't just leave it blank because it's A to the 0, B to the 0, so just don't write it down. That's when you have to put the 1 down. All right. Here's another one. I know it's a little bit blurry, but I tried copying and pasting stuff in there, trying to do it that way. So if we look at this one, what are we going to do first?
Yeah, throw the C up there.
Throw the C up. If you throw the C up, you're going to have A to the negative third. What about that B to the 0? Just take it out. It's the number 1. You can put the 1 as a coefficient there, but it's understood to be there, right? If nothing else was there, we would want to make sure we had it, but it's understood to be there right now. You throw that C up, as Joseph said, and it becomes C to the negative first. All right, so then we go to the first term in parentheses. Once again, you got to throw that C up. C to what power? Negative second. So now if I simplify that, you have A squared, B, C to the negative first. Throw the B up, you get B to the second. So minus 3, A to the negative second, B to the second. And now what do? You distribute, right? So I need to take this, red, times the green. When you multiply them together, what do you get?
A to the negative 1. B is negative 2. And you have B. Oh, no, B.
It's okay. You can put the C first. It's just that I have my dot to start the B. And I didn't want to erase the dot. So yes, you could have A to the negative first, C to the negative second, B. That's okay. All right. Then we're going to distribute the second to the second term inside the parentheses. So now I want to take the red times the blue, and you end up with negative 3. A to the negative fifth.
E. And B.
And B squared. Yep. There you go. You can't group those together because they're not like terms or anything. They don't have the same variables raised to the same power. Question? See where those values come from? Okay, so the next thing, that's just a little bit of the distributive property. Solutions of equations, we have the addition rule. Anything that's added to one side of the equation can be added to the other side of the equation without changing the value or the solution of the equation. We can do the same thing with subtraction. Subtraction is the same thing as adding a negative value. So you can add or subtract the same value from both sides of the equation and you're going to be fine. The second thing is third thing maybe, third and fourth. You can multiply and divide both sides of an equation by the same value without changing anything. Without changing the solution or the answer to the equation. Your solution set will still be the same. Non-zero quantity, because can you divide by 0? No. Remember, no, you cannot divide by 0. But it's okay to take 0 and divide by a number, right?
Yeah.
What's your answer there?
0.
0 divided by 5 is 0. All right, then we have something that's called equivalent equations. And you've had this before. I don't think this is in this book. I think it was last year. I probably asked you, what are equivalent equations? Equivalent equations are equations that have the same solution set. The same value, the same x values will make the equation true. It doesn't have to be x because it could be any variable that is put in there, but it has the same solution. So we solve. We want to solve this type of problem. We've worked with this before. Some of you are used to putting the line down. Refresh your memory from last year. And the first thing, do you remember what you want to do is the first thing?
Yeah, get like x on one side and just
eventually we want to get there. Is the left-hand side simplified? Is this the simplest way we can write this? No. So we want to simplify the left-hand side and we want to simplify the right-hand side. How do I simplify the left-hand side? Yeah, the distributive property, that's like a -1. So I want to distribute it to those two values. So you're going to get 12 minus 2x minus 5. A negative sign in front of the parentheses says change the sign of every single term inside. Distribute it. Is that simplified now? No. Because what can you do with these two terms? Throw them together and you get 12 minus 5, which is? That's a -5. So you have 12 minus 5, which is 7. So you get 7 minus 2x. Now is that simplified? Yes. We also want to simplify the right-hand side. And if I simplify the right-hand side, what about those parentheses? That's like a +1. So you have -2. Distribute that. You're just going to get x minus 3. What if you group those together? -5 plus x. Because those two are like terms, correct? All right, now what do you do from there? Put the x's on one side, numbers on the other. Does it matter which way you go? No. How many put the x's on the left? Over here. How many put the x's over here? How many make them positive? Okay, I don't care which way you go with it. It does not matter. The end result will be the same. Okay. So I think some of you were in the habit of doing this. If I move this x over here, what does it become? If you change the side, you change the sign. It's being added, so you want to subtract it. If you do that, you got to take the number and you got to move it over to the other side. Some of you did the arrows. Some of you just said, well, it's positive here, so it's going to be negative here. And you didn't even put that I'm going to subtract it there. Whichever way you've done this. Because these are additive inverses. I moved it over, so I changed the sign. I moved the x over, so I changed the sign. And on the left-hand side, you get -3x. On the right-hand side, you get -12. As the final step, you have to divide by -3. The x stays there because these cancel. -3 over -3 is 1, so you get x is equal to, what's -12 divided by -3? 4. There's your answer. If you would have moved them the other way, if you would have moved, so if we had 7 minus 2x equals -5x, or -5 plus x, if you move your 2 over to the other side, it becomes positive 2x. If you move your -5 over, it becomes positive 5, and when you group those together, you get 12 is equal to 3x, and if you divide, you get x equals 4 again. So it's the same thing, it's just that your signs are going to be different when it's on the other side, but as you divide it, you will still get the same answer. I don't care which way you move them. I tried to get the consensus and do it the way that the majority of you did it, but I really don't know if I got a true what way you do it. Maybe you alternate. I don't know what you do. Okay, you're confused with the question? Like, how many would do this way? Now that you see it, how many would do this way? I think it looks like it's all the guys. How many do it this way? Yeah, okay, I have a couple that are like, I don't know. Oh, you're the one that goes it this way. I don't know. Some people just like to be consistent with the x on the left-hand side. You divide by the coefficient of x. Okay, what if I gave you this one and I asked you to solve this problem? One, you don't like it because of what? There's fractions involved. Okay, the first thing, let's just simplify each side. That's what you always do first. If I simplify each side, I have to take this 3 and I have to distribute it through, correct? So I'm just going to do this. I'm going to take 3. There's my 3 right there. I need to take 3 times 5/6, and I need to take 5/3 times 3. Did that just make it confusing for you? Okay. I won't show it that way. We'll leave it like this. So I need to distribute. You take 3 times 5, 6. What is 3 times 5 over 6? This is over 1. 3 goes into 6 2 times, and you get what?
5 over 1.
No.
5 over 2, I mean.
5 halves. And then I subtract. I need to take 3 times 5 thirds. What do you get when you take 3 times 5 thirds? 5 over 1, or just 5x. Is that simplified? Yeah, I can't group those 2 terms together, can I? I have a constant and I have my variable. All right, this is a 1, so I want to distribute -1 through, and you end up with what? 1/2, because a negative times a negative is a positive. -1 times x is -x. Okay. We want to move the, I don't know which way you're going to move it. Okay, first thing I heard was x over this way, which makes it what?
6x.
It makes it a positive x. So what's -5x plus x?
4.
-4x. If I move the x to the left, I got to take the constant, move it to the right. So it becomes -5 halves, right? You change the sign. What is +1 and -5? Who wins? Negative by 4. They have that common denominator. What's -4 halves the same thing as? -2 over 1. So this is the same thing as -2. What do you do as your final step?
Divide.
But what do you divide by? The coefficient of x. So you have to divide by -4. A negative divided by a negative is a positive. 2 fourths reduces down to 1/2. A lot of people want to put 2. Mentally, we don't like to think of fractions. I don't want a part of a dollar. I want the whole dollar. I don't want half of a $10 bill. I want the whole $10 bill. You get 100 and you hate to break it. So people like the whole numbers. So most of you could get this correct in that very last step. You're just accidentally going to say it's 2 instead of 1/2. When I draw arrows to an answer, if you said your answer was 2, and if I were to do something like this, that means you divided the wrong way. Your answer should be the reciprocal because you divided the wrong way. Now, what you were noticing that last time when we were working through it, if you change the side, you change the sign. And that's all we did here. I said, if I'm going to move this x over, it becomes positive. If I'm going to move that 5 halves over, it becomes negative. Just change your sign. That's all that says. Change the sides, you change the signs. That's known as transposition. So if I ask you, here's the other way that you're going to use it, is if you have more than one variable. What if I ask you to solve for y now? You want y by itself, right? So I need to take everything that's on the same side as y and move it over the other side. If you move it over, what does it become? Negative. So you have a -2x, and that's a +4. This is okay. This is the same thing. 4, and if I move that over, it becomes -2x. I cannot, so either one of these answers works, okay? I cannot group the 4 and the -2 together. Why? They're not like terms. Why are they not like terms? 4 doesn't have an x. So they are not like terms, so you cannot group them together. Okay. So you're left with the 2 terms in your answer. This gets you 2 equations for lines. You can graph them very easily. The coefficient of x is your slope, which means at what angle does it go at. And the constant is where it crosses the y-axis at. So you can get into graphing those, which you're going to at this point. If I ask you to solve this one for x, this one people can do fairly easily. You got to move the 2 over to the other side by +2. So what is x equal to? 9. Well, we could do that in our head because we know that 9 minus 2 is 7. Come on, Mrs. Judge, challenge me just a little bit. So if I give you this, that challenges you a little bit. What do we want to solve for? P. So what do I have to move to the other side? The 3x has to move over. It's negative, so it becomes positive 3x. I got to move the 4 over, so it becomes negative 4. And you get P is equal to 7y plus 3x minus 4. Probably not much work you need to show on your homework. As you go to write this down on your paper, mentally you're going to move that over, change the sign. Solve for y. This one's just a little bit, it's got one more step involved. If I solve for y, we're going to move the 2x over, the negative 2x over, making it positive 2x. I have to move the 5 over, making it negative 5. And if I perform just that step, you get 3y equals 2x minus 5. What did they want you to solve for? Y. Do I know what y equals? You don't. Think about this. If I give you a problem that looks like this and I told you this was 80 and this is 2x, what is x? Try again.
Oh,
What did
no,
you say?
it'd be 50.
What did you say? Not 80 divided by 2.
It'd be 100.
You have this straight line right here, which is how many degrees? 180. So this, just this part over here is how many degrees? 100. So what is x equal to? 50. This is not solving for y. What do you have to do to solve for y? Divide by 3. We're going to divide each side or each term. If I divide this side by 3, it's the same thing as splitting them into separate fractions. So what is y equal to? 2/3 x minus 5/3. And all that says is to graph it. This constant right there, negative 5/3, that's where it's going to cross the y-axis at. Then you're going to have a slope of 2/3. You're going to go up 2 over 3, up 2 over 3, down 2 over 3, and you can graph your line very easily. That's the reason you're wanting to be able to solve for y. Now I realize if you get p is equal to x, y, 7, something like that, you're like, oh. You can get into 3-dimensional. You get into what's normally x, y, z, not p. But you can have a point where you go up, over, and out, or back in your 3 dimensions. Okay. Questions? Exit ticket. What you need to do is turn to page. Page 37, I want you to do A and B on page 37. Monday, here's what you're going to be working on. On Monday, when I work with the other group, you will be working on page 37. I would just let it right there, please. Yep, thank you.